So to start off, just kind of foundationally, how we do our block models is they actually start out as JSON here. This defines what textures they have on which side. For example, this is a grass block. It's grass siding and then grass full on top and then dirt on the bottom, which makes a 3D rendered block of grass. And then the texture array is also something else that we use as well, because these are the actual 2D textures that will be mapped to the sides of the blocks. So we put those together and then we get the actual 3D rendered block. And we can use this block for two things here. Now, the first thing, which is kind of obvious, we use it to actually build the terrain here with some help from simplex noise. The other use case that we just implemented is actually icon rendering and animation rendering, really, for the inventory. You have the animation in this upper right corner, and then the block icons in the actual slots when you don't hover over them. When you do hover over them, of course, the animation actually plays, but this is kind of the two uses so far, at least, we have for this 3D rendered block object. Now, if we take a look at the render doc, we can actually see on the very first frame, actually, is what we are doing. We are actually creating a texture atlas that has our icons in it. So if we go to the resource called Icon Atlas, we can actually see, if we zoom out a lot, we can actually see grass block, dirt block, way down here in the corner, because this is a 4096 by 4096 texture atlas. And then if we click on these, we can get more and more blocks. They are all their own draw call, which is not the best way to do it, I'm aware. However, this cannot be an asynchronous function right here. They have to be one at a time, which is why I have these GL finish functions between them. So this is going to make a texture atlas that we can actually sample from once we actually get to our inventory. So if we look at our textures, we can see that the slots being rendered, it renders the slot itself, and then it goes ahead and renders the actual block icon for these first 6 slots. So it'll sample those textures from that atlas once needed for the inventory. Then it just renders the rest of the empty slots as they are. So this is a function that actually will generate the texture atlas here. You can see that I'm setting my matrices here for the actual rendering to the texture. And then this loop is actually what handles drawing of each block to the texture. Obviously, it's going to skip over air because we don't actually have any textures for air. And then you can see it will set the viewport to a specific region of the texture that we need. It'll wait for the all of the draw calls to finish. It'll wait for all of the bindings to finish. It'll wait for everything and pretty much just make this a synchronous operation here. And then it's going to actually update our SSBO. This SSBO only has 6 instances for 6 block bases of the block. Every loop, it's just going to update the block type in that SBO just to the next one. So we end up with one of each block type in the atlas. And then the draw call, pretty straightforward. We have 6 separate draw calls for the 6 separate block types. I try to keep my draw calls to a minimum, but I don't think I have much of an option at this point. I kind of just have to get it over with. This is only running on load, so it's not going to be a huge tanked performance because it's just doing it once a single time. And then this is just the restoration of the state what it was before this function was even called. These icons are actually 128 pixels, and the actual animation texture that's at the top of the inventory is 256 pixels by 256. I figured that was the best resolution. Any smaller, then it looks a little bit pixelated. Any larger, I think, is unnecessary, really, because the larger we make it, the more space we're taking up in our texture atlases. So I think right now, these are perfect sizes, and the actual block face textures themselves are only 16 pixels. By 16 pixels, we have more than enough texture atlas space for that, but in terms of resolution, we really don't need that much more than what we have right now. And also, if you'll notice, this is completely upside down. However, when you look at it in the game, it's actually right side up. It turns out, I'm not sure why, but for some reason in memory, the textures are upside down, and I actually render them, they are right side up. Conversely, if I were to turn them right side up in memory, or on the GPU rather, they would show up upside down. There used to be an issue with actually my view matrix and my model matrix, is the blocks are right side up in my memory. However, the actual view matrix is not correct. This is looking at it from a bottom-up perspective, while in the actual game, it is looking at it upside down still. Yeah, that's something I discovered. I'm not quite sure why. Probably something to do with how I'm rendering it, how my matrices are set up, most likely. But for now, that's how it is. All right, well, that's going to be it for this deep dive here for the 12th devlog. Let me know if you like this new format of videos I'm doing. Just a shorter demo video and then like one of these longer deep dive videos for those that are interested in that. But I will see you guys in the next video.